Welcome to Integrated 2. Make sure you write your 7-4 in the top left-hand corner and your information in the top right-hand corner. Notes: probability with permutations and combinations. So, a permutation is arrangement of objects in which order is important. So we can use the fundamental counting principle to figure out the number of permutations that could happen. So say, for example, you have 4 cards labeled 1, 2, 3, and 4. So what are the choices you could have for the first card you picked up? There could be 4 of them. Now, if you put that down, what's the next card you pick up? Now, there could be 3 different choices. Let's say you picked 1 at the very beginning. Well, you'd still have 2, 3, and 4. So on the second choice, you have 3. Now, on the third drawing, there's only 2 other cards left. And then finally, you only have 1 card at the very end. So remembering that the fundamental counting principle, we could multiply these, and so the total permutations of this example would be 4 times 3 times 2 times 1, or 24 different permutations. So this is an example of like a factorial, n exclamation mark, or n factorial. So you would start at the very beginning. So if you had 52 cards and you had to make sure, like, what are the total number of different possibilities? It'd be 52 times 51 times 50 times 49 times 48 times all the way down. All right, let's go on. So we're going to talk about probability and permutations of n objects. So performing arts. Taisha and Liam sign up for an open mic night with 32 available slots that are filled at random. What is the probability that Taisha will perform first and Liam will perform second? So first up, the possible outcomes that we would have would be 32 factorial, because each one of those people could go first. All right, next up, favorable outcomes. So we understand that, we'd have Taisha first and then Liam second. So out of a total of 32, we already know, hey, look, these 2 are going to go first. So after that, there's 30 factorial after that. So it could be Taisha, then Liam, and then Fred, or Taisha, then Liam, then Johnson, then Taisha, then Liam, and then Bill. There's 30 factorial different outcomes that could happen. So the probability of Taisha going first and then Liam going second would be 30 factorial over 32 factorial. But we can cancel this out. We understand that this would be 32 times 31 times 30 factorial. And so, what is 30 factorial divided by 30 factorial? It's 1. So then I would just have 32 times 31. And 32 times 31 is 992. So the probability of Taisha going first and Liam going second would be 1 out of 992 times. All right, we're going to go on to example 2 in 5, 4, 3, 2, 1. All right, so we have example 2, probability and permutations with no repetition. So for a project, Rami selects, and I want to remind you, you don't have to write the red, okay? Rami selects 12 family photographs that will randomly play in a slideshow. The slideshow will not show repeat photos until all 12 photos have been shown. 3 photos are of Rami's entire family, 2 photos are of his brother, and 3 photos are just of him, and 4 photos are of his sister. What is the probability that the first 4 pictures in the slideshow will be of Rami's sister? So the possible outcomes. So for the order is going to be important. The number of possible outcomes in the sample space is the number of permutations of 12 photos taken at 4 at a time. All right, so there's going to be a formula on this. So 12 permutations of 4 will be 12 factorial over 12 minus 4 factorial. Which would be 12, well, let's do the bottom first. 12 minus 4 would be 8 factorial. So now let's set this up. This would be 12 times 11 times 10 times 9 times 8 factorial. So what is 8 factorial divided by 8 factorial? 1. So now we just have 12 times 11 times 10 times 9, which would be 11,880. That's a lot. Now, out of all these, what are all the favorable outcomes? Let me set it up for you. All right, so just remember there's 4 photos. So, how many different, let's do the permutation. So, pick any of the 4. That'd be 4. And then the next photo has to be hers, so it would be like any of the remaining 3, or any of the remaining 2, or any of the remaining 1. So that's going to be 4 factorial. All right, so now what we're going to do is we're going to take this information and now we're going to calculate the probability. So the probability is going to be 4 factorial over 11,880, or it will be 1 over 495. All right, that's example 2. We're going to go on in 3, 2, 1. So, example 3, probability and permutations with repetition. Find the probability of arranging the letters in Miami. All right, so if we are doing that, we have to figure out how many total are there. So we know that it's 5 factorial. There's 5 numbers here. Now what we do know is when there's repetition, we can take that. So for example, how many m's are there? There's 2. So we're going to have 2 factorial times, is there any other repetition? The I. And so we're going to times that by 2. And so that would be, we could cancel that out. 5 times 4, sure, why not? Times 3 times 2 factorial. In reality, 2 factorial is 2 times 2, so that would cancel out this 4, and we'd be left with 5 times 3 times 2, 6 times 5, that'd be 30. And so the probability would be it'd be 1 out of 30. That would be what the probability is for this. But there'd be 30 different arrangement of these. All right. So basically what they're going for this is, hey, we could switch out the M's, it doesn't matter. We could switch out the I's, it doesn't matter. It would be the same, the first, if we switch the M's, it would look the same. That's what this part right here is. We're taking out, hey, look, we could take this out, we could take out the I. All right, let's go on. All right, one last thing before we go on. Tallahassee, that might be on your quiz or on your test, so be prepared for that one, okay? We're going on, but I'm throwing it at you right now just for you to look at. All right, so learn. Probability using combination. A combination is a selection of objects in which order is not important. So technically, if you buy a lock for, a sports locker, you are not buying a combination lock, you are buying a permutation lock. Permutation, we care about the order. Combination, we don't really. So a combination of n objects taken r at a time, or n combinations of R is calculated by dividing the number of permutations n of R by the number of arrangements containing the same elements R factorial. So example 4, probability and combinations. If 3 points are chosen from those named on pentagon ACEG J, what is the probability that they all lie in the same line segment? Find the number of possible outcomes. Alright, let's set it up and go. Alright, so there are 10 points. So we're going to have 10 factorial. And now we're going to have 10 minus 3 factorial. And then we have 3 factorial. So let's set this up more. Let's figure this out. Alright, so if we simplify this, we'd have 7 factorial times 3 factorial all over 10 times 9 times 8 times 7 factorial. 7 factorial divided by 7 factorial will be 1. And then we still have 3 times 2 right here. So if we cancel this out, we'd have like 10 times 3 times 4. So that'd be 120. There are 120 different possible outcomes where, the order doesn't matter. That's what it's saying. A combination, order doesn't matter. In a combination lock, the order matters because it is a permutation lock. Now we have to find the favorable outcomes. So let's write them down. I'll let you write them down. Alright, so looking at this, there are 5 different line segments that will work for us. Line segment AC, CE, EG, G, J, or JA. So these are the number of favorable outcomes. To calculate the probability, take that 5 and divide it by 120. And we would get 1 over 24. Alright guys, I know permutations can be hard. I'm going to add a different video for you, but I hope you guys have a great day. See you at school. Bye.